Hey guys, this is Ms. Lackey again. In this video, we're going to be looking at how you're going to name acids and bases. So acids are compounds that contain one or more hydrogen atoms that can produce hydrogen ions when dissolved in water. So these are actually going to start with hydrogen as that first element. An acid will have an anion combined with as many hydrogen ions as needed to balance the charges. So these are still going to be written using our ionic naming rules and stuff, but they have a different way of being named, but the formulas are still going to be like other ionic compounds. It's not changing slides. There we go. The chemical formula for these, like I said, they are going to start with hydrogen. So they'll have this HNX form. The H is how many hydrogen ions there are. The X is the anion. This can be monatomic off the periodic table, or it can also be a polyatomic ion. And the N is the subscript on the hydrogen, telling you how many you need to balance charges. This is after crisscrossing charges, like other ionic compounds. So looking at naming acids, there are 3 different rules for naming acids, depending on what the ending of the anion is. So if the name of the anion generally ends in IDE, so these are going to be those monatomic anions off the periodic table, or the polyatomic ion cyanide. The acid name is going to have the prefix of hydro, the stem of the anion name, and it's going to have the ending of IC followed by the word acid. So in general, it will be hydro, the main part of the word, ic acid. So let's look at a couple of these. We have HCl. Remember, Cl is chloride, so it does have that IDE ending. So using our rules, it will have the prefix of hydro, the main part of the name, so the chlor, and then end in ic acid. So HCl is hydrochloric acid. Looking at the next one, H2S. S is sulfide with that IDE ending. So this will have the prefix of hydro. It'll have the sulfuric, sulfur, and then the ic, followed by the word acid. There we go. So hydrosulfuric acid. Let's look at our next type. Our second rule when naming acids are with our anions that end in ITE. So those polyatomic ions that end in ITE. These do not have a prefix. The acid name is the stem of the anion, and it's going to have the suffix or ending of OUS followed by the word acid. So this will be the main part, OUS acid. So looking at our example, we have H2SO3. SO3 is sulfite. So we're going to take the main part of the anion, so the sulfur part, and this is going to end in OUS with the word acid. So this will be sulfuric acid. Another example is if you have something like nitrite, it will be nitrous acid. And then our third rule is whenever those anions end in ATE. So these are the rest of our polyatomics. These yet again do not have a prefix, but it has the stem of the anion with the ending of IC followed by the word acid. So the main part, ic acid. So looking at HNO3, NO3 is nitrate. So we're going to have the nitro part, and it's going to end in ic acid. So this is nitric acid. Same thing if you had like phosphate, it would be phosphoric acid. Now, writing formulas, you're going to use those same 3 rules to determine what the anion is, but you have to crisscross charges like you would with any other ionic compound. So let's look at hydrobromic acid. This does have the prefix of hydro, so that means this is that first rule. So we're looking at bromide as our anion. So bromide is off the periodic table, so that's a Br with a -1 charge. Because it's an acid, it starts with hydrogen, which has a +1 charge, and you have to crisscross your charges, so you'll end up with HBr. Let's look at some more examples. We have phosphorus acid. This does not have a prefix, but it has that OUS acid ending. So this is that second rule where this is phosphite. Now, phosphite is not on your reference sheet, but it is another polyatomic that we can come across. The formula for phosphite is PO3 with a -3 charge. Since it is an acid, it starts with H, which has a positive charge. So this will end up being H3PO3. And then our last one we have here is carbonic acid. This does not have a prefix, but it ends in ic acid. This means that we're dealing with carbonate. So carbonate, if you look on your polyatomic list, is CO3 with a -2 charge. Since it is an acid, it begins with hydrogen. So this will be H2CO3 when we crisscross charges. These are some of the most common acids you're going to come across, so make sure that you are familiar with these. We already did HCl, was hydrochloric acid. HNO3, NO3 is nitrate, so this will be nitric acid. SO4 is sulfate, so this will be sulfuric acid. And then this last one, the C2H3O2 is acetate, so this will be acetic acid. So those are some of the most common ones that we are going to come across. Let's switch gears and look at bases. Bases you've actually already been naming without knowing it. So base is an ionic compound that produces hydroxide ions when dissolved in water. So these are going to be ionic compounds that end in hydroxide and have that OH at the end. So these are named just like other ionic compounds. It's the name of the cation followed by the name of the anion, which is hydroxide. So for example, NaOH, Na is sodium, and OH is hydroxide. Make sure that if your metal, that first cation, is a transition metal, that you use the appropriate naming system and Roman numerals for it. On the flip side, if we're writing formulas of bases, this is just like writing any other ionic compound. You have the metal cation, and then hydroxide, and you crisscross the charges to balance. So for example, we have calcium hydroxide. Calcium is Ca with a positive 2 charge. Hydroxide is OH with a negative 1 charge. So whenever we crisscross, remember whenever you add a subscript to a polyatomic, you have to put in parentheses. So we have CaOH2. This is the last of nomenclature. Make sure that you are finishing all of your practice homework, and tomorrow we're going to look at putting all of these together.